Resonance today topic is resonance and mesomeric effect. Is both are same or different? This is the question now. See, resonance is the big phenomena. In that resonance, mesomeric effect is the part. So without resonance, there is no mesomeric effect. That's why we are learning first resonance effect. If you learn resonance, then mesomeric effect you can understand easily. So first, what is resonance? The resonance refers to delocalization of electrons in a given system. Delocalization means moving electrons, shifting or migrating electrons. That is delocalization. Resonance refers to delocalization of electron. Resonance is telling about how the electrons are moving. Mesomeric effect is the electron donating or withdrawing nature of substituent due to resonance. Due to that resonance, a group of atoms or atom is either it is donating or receiving electron. That part of the atom or group of atom is known as mesomeric group. Suppose benzene is there, benzene attached OH is there. This OH has a lone pair. So this lone pair is donating to benzene ring. This donating nature, this pi electron shifting to benzene ring, this benzene pi electron shifted to benzene carbon. This nature is called resonance. Here this OH group is mesomeric group. This OH group is mesomeric group. Mesomeric group. Now I think understood. Resonance means this phenomena, this delocalization of electron is resonance. In this delocalization, the group which is donating electrons, that is mesomeric group. The group which is electron receiving, also mesomeric group. Okay, but to understand the mesomeric effect, you have to learn what is resonance. These are interconnected. Now, first resonance. These resonance structures are helpful in explanation of chemical reactivity or the chemical reaction of the compound. That's why we can say a resonance phenomenon is the result of mesomeric effect or delocalization. Number one, resonating structures are not the real structures of conjugated compounds. What is a conjugated compound? Conjugated means alternative position. If double bond is there, that is conjugated system. Alternative position. Not only double bonds, double bond plus positive charge, double bond plus negative charge, like this. Resonating structures are not the real structures of conjugated compound. The real structure of conjugated compound is a hybrid of all resonating structures. This phenomenon is known as resonance, mesomerism, delocalization. You can take one example here. Suppose benzene, well-known compound, that is benzene. So these two structures. So here if I give the numbering 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. In the first structure, you can see in between 1 and 2 double bond is there. In the second structure, in between 1 and 2 single bond is there. So which structure is correct? So both are correct. If both are correct, then how? Here one single bond is there, here double bond is there. So these two structures are not real structures, these are resonating structures. These are resonating structures, these are resonance, benzene resonance structures. Right? So what is the real structure then? The real structure is this is also known as hybrid structure. How we written this hybrid structure? The summary of the resonance structures. What is telling this first resonance? It is telling that in between 1 and 2 carbon double bond is there. The second structure is telling in between second and third also double bond is there. So I am writing all dotted, 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 dotted. That means this pi bond nature is moving random continuously. Okay, there is no particular pi bond in between two carbons. It is there in between all carbons. That's why in the benzene there is no C single bond, C double bond, C. The bond order, if you calculate, the bond order is, we can say 1.5 is the bond order. More than one bond, less than two bonds. And according to this structure, here bond length should be different. Here it should be short and it should be long bond length. But in the benzene, practically all are same. All CC bonds length is all same bond length. So that thing we can explain by only hybrid structure. We cannot explain how CC bond length is same in between all carbons by any one of these resonance structure. We can explain by only one hybrid structure. Okay, so the hybrid structure is the main real structure, we can say. Now, the third point is the resonance is nothing but hybridization of resonating structures, and resonance phenomenon will takes place in conjugated compounds. Conjugated compound means, already I told you, alternative position it should be. Here you can see pi bond, single bond, pi bond, single bond, pi bond, like this. Then only it is conjugated system. Suppose here pi bond is there, here pi bond is there. No conjugation. No conjugation. Conjugation matlab it should be alternative position. Okay, not only pi bonds, it may be pi bond, positive charge or negative charge, or lone pair, or vacant orbital. Okay, any one of these, one pi bond and remaining place any one of these in the alternative position it should be. Then this is called conjugation. Now, conditions for resonating structures. For resonating structure, what are the conditions? The first condition is all resonating structures must have the same arrangement of atomic nuclei. Same arrangement of atomic nuclei. We written in the benzene ring. Okay, while you are writing the resonating structures, the pi bonds can move, but the carbon atom should be same position. This carbon atoms, hydrogen atom should not be changed. That is the meaning. The resonating structures must have the same arrangement of atomic nuclei. Resonance differs from tautomerism in this very important aspect. Okay, tautomerism, you know that tautomerism, keto-enol tautomerism, CH3, CH3 is there. So here one hydrogen is shifting like this, it's going. So this oxygen, this hydrogen shifted to oxygen, 1 comma 3 migration. Here double bond it is getting. So this is the tautomerism. Here it is a ketone. This is the enol. Double bond is there in, alcohol is there all, enol. So this is known as keto-enol tautomerism. Tautomerism. Okay. So these two are not resonating structures. That is the telling. These are, note point is, these are not resonance structures. Why? Because here hydrogen is shifted here. Okay, so this type of structures are not called as resonance. Resonance means the benzene, that is the perfect resonance. Only pi bond should be changed, the atoms should not be changed. Okay, that is the resonance. Second point, the resonating structures must have the same number of paired and unpaired electrons. However, they differ in the way of distribution of electrons. Resonating structure must have the same number of unpaired and paired electrons. However, they differ in the way of distribution of electrons. So if you count the number of electrons, it should be same. You can see here number of unpaired electrons and paired electron, you can count it here. So both are same. See here. How many sigma bonds? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 sigma bonds. Here also 5 sigma bonds. Okay. So like this. The energy of the different resonating structure must have the same or nearly the same. Okay. Randomly you cannot write any structure. Okay, the resonating structure means existable, stable structures only you have to write. Resonating structures must be the same or nearly the same. Then all atoms that are part of the delocalization system must be in a plane or be nearly planar. So this resonating structure is possible on the same plane. Same plane hai to possible. All atoms of the resonating structure, all atoms of the resonating structure should follow the octet rule. Octet rule also must be followed. You can see these examples here. This is regarding octet. Octet rule. See here, nitrogen does not follow its octet rule here. So in the first case, it's okay. Nitrogen has how many bonds? Total 4 bonds. Fine. Nitrogen, it never forms 5 bonds. 5 bonds it never forms. Okay. So if you take like this, it is not ready to take the electron. Sir, positive charge is there, that's why pi electron is shifting. No. If you count this number of electrons, how many electrons? Total 3 plus 2, total 10 electrons are there. How many bonds? 5 bonds are there, 5 sigma bonds, total 10 electrons. And if you take here, nitrogen does not follow its octet rule, hence second is not resonating structure. It's over. Next, here pi bonds paired and unpaired, or we can say lone pair. These electrons should be same number of paired bonded electrons and non-bonded electrons should be same. Then see here, these two are resonance structures. These two are resonance. Okay, here just pi electron shifting, but see here this hydrogen is shifted here, the hydrogen is shifted here, so these are not resonance structure, resonating RS. These are not resonating structures. Conditions for resonance, yeah, already I discussed again once. For resonance, either it may be two pi bonds alternative position, pi bond plus lone pair, pi bond plus single electrons, pi bond plus negative charge, pi bond and positive charge, pi bond and vacant orbital. In these 6 conditions, the resonance structures are possible. These 6 conditions. Note point is, electron kabhi bhi higher density to lower density migration takes place. Okay, suppose pi bond and lone pair is there. This lone pair will be start shifting first migration. Okay, here two pi bonds are there. There is no problem. Here negative charge is there. Obviously, negative charge will start first. Here plus is there means obviously positive charge will be start migrating. Here vacant orbital means like this. Okay, higher density to lower density. And each one example we will discuss. Whenever two pi bonds are in conjugation, you can see I will take example for this. This is the condition. Two pi bonds are there. Now, one is a possibility this pi bond is shifted here, this pi bond is shifting here. So I can write here this M shape is there, here positive charge, double bond, negative charge. This is one structure, resonating structure. And one more structure I can write, this pi bond is shifted here, this pi bond is shifted to edge carbon. Then again I am writing this M structure, here negative charge, here pi bond. This one is positive charge. Why? Because this pi bond shifted means here bond electron deficiency ho gaya. That's why positive charge. Here electron shifted completely. So negative charge. So these two are also resonance structures. Okay. Resonance structure, either it may be two possibilities are there. Right side and left side. So these two are called resonance structure. Right. You can see these two structures are there. Now pi bond is there and two pi bonds. Now which structure? Of course two possibilities are there here also, but this possibility is more. Why? Due to higher electron negativity, first this pi bond is shifted to oxygen side, so partially positive charge on the carbon. So this pi bond is shifted, right? Higher electron density to lower electron density. Okay, this is the resonating structure. Then here it's okay, fine. Next, condition 2, lone pair and pi bond is there. In that case, obviously I told you lone pair will start first, then this pi bond shifted here, this is getting negative charge, right? Now this negative charge, obviously it is shifting here, so this carbon is getting negative charge, then lone pair is there, it's okay, it will be start first. Now case 3, if there is one positive charge and one pi bond at alternative position, then electron of pi bond are transferred towards positive charge. Obviously more electron density to less electron density. So this pi bond shifting here, so here pi bond forming, this carbon getting positive charge. Note, point is here, like this pi bond is cannot shift to oxygen side, because if it is shift here, it is getting negative charge, here getting positive charge. The positive, it is very unstable. Adjacent same charges are unstable, that is forbidden. Means the resonance, such type of resonances are not possible. Adjacent minus minus and adjacent positive, these type of resonance are as not possible. Okay, adjacent positive, adjacent negative should not become. Next, fourth, if there is one free electron, in single electron, one pi bond is there at alternative position, then isko chahiye to only one electron, so this bond is homolytic cleavage takes place. So these here one electron, these two electrons are forming bond here, here unpaired electron is there. Okay, next. Here lone pair is there, it's going back, so carbon, this is allowed because here there is no plus. Okay, so this is allowed. Now Characteristics of resonance. In resonance, only electrons are transferred, not atoms. This point which discussed starting. In the benzene ring, only pi electrons are shifting. Okay. So in the resonance, only electrons are transferred. That too, pi electrons and lone pairs. These are transferred. The number of electrons or number of unpaired or paired electron in all resonating structures should be same. Third point, the energy of resonating structure is almost same. Energy of resonating structure almost same. It is permanent effect. Of course, it is a permanent effect in the benzene ring continuously roaming. All the resonating structure and canonical structures must conform to Lewis structure. See, this point again, the resonance structures almost same. So that is example just now you can see here this one. I can write here the structure CH2 plus bond C plus oxygen minus. So I can write this structure, but it is not possible. Why? Because it is very unstable. Very unstable. Unstable. That's why it is not possible. Okay. So that point meaning is the energy should be same. Energy should be same means almost stable resonance structures you have to write. Next, a few more examples. Draw the resonating structures. It's very important. Lone pair is there. Obviously, lone pair will start migrating first. Then immediately this carbon getting 5 bonds. So immediately the pi bond is shifted to here. Then ortho position, this position getting negative charge. Then this negative charge is going back. Then the next is continuously roaming. So how many structures? 1, 2, 3, 4, 5. The fifth one is again same structure. So resonating structures are forming like this. Whenever negative charge is there, negative is coming back. So here you can see benzene structure is every carbon has one hydrogen like this. Yes. So here OH is there, either CH2 minus whatever it. So whenever this lone pair is giving back, see this carbon has how many bonds? 4 bonds already. So if you give the lone pair here, how many bonds it becomes? 5 bonds. That's why immediately this pi bond is shifted to here. So then how many bonds it will be? No problem. After making minus here, 1, 2, 3, the minus is 4. Okay, that's why this one. See here one hydrogen is there. Okay, 1 bond, 2 bond, 3 bonds. 3 bond plus 1 lone pair is there. That minus charge. So no problem here. 5 bond, it should not be 5 bond. Carbon never form 5 bonds. Okay. So next here CH2 plus is there, electron higher to lower. So pi bond is giving to CH2 plus, then benzene carbon getting positive charge. To neutralize this pi bond shifted here, then this carbon getting positive charge, then again this carbon getting positive charge. You can see here again it's continuous. Okay, sometimes here there is no positive charge, even though this pi bond alternative position. Already we talked pi bond, two pi bonds are in conjugation. Conjugation means alternative position is there, then resonance will start. Now this which bond will start first? Obviously it is more electronegative atom, so partially positive charge will be here. So this pi bond is shifted to here. Okay, so similarly this dotted electron this CH2 need only one electron, homolytic cleavage, then here radical. So this free radical, it is called free radical, also considered like electrophile, because it is also electron deficient. Next, here lone pair is there, lone pair is giving back, so this carbon getting negative charge, then it is coming back, so here negative charge, you can see. Now we are writing hybrid these resonating structures. So from this, what is the conclusion? Conclusion is that from this resonating structure we can say that suppose ये compound है, इसमें कोई double bond नहीं है, कोई single bond नहीं है. Okay, if you write this average structure of this like this, इसका मतलब ये है there is no single bond, there is no double bond. Here in between carbon and carbon, more than one bond, less than two bonds. Okay, so what is the bond order? In case of bond order, how you will calculate? See, total how many bonds are there? 1 2 3 4 5. Total 5 bonds are there. Total bonds upon how many sigma bonds? 1 2 3. 3 sigma bonds. So that means 5 by 3, that means 1 point, how much? 3 1 are 3, 2, approximately 1.66 like that, 1.63 something. Okay, so this is the bond order. Now resonating structure, this is called hybrid structure, this dotted one. Hybrid structure is the sum of this all resonating structures. Actually this is the real structure also, we can say. Next, now resonance energy. Resonance energy, what is this resonance energy? The difference in the experimental and calculated energy. Which energy? Heat of hydration energy, by which the compound is stable, is known as resonance or delocalization energy. Higher the value of resonance energy, greater is the resonance stabilization. First of all, you have to know that heat of hydrogenation means what? See, heat of hydrogenation means while hydrogenation takes place, you can see here, while hydrogenation takes place, some energy is releasing. This energy is known as heat of hydrogenation. Heat of hydrogenation. Okay, so one bond is there, that time hydrogenation takes place, releasing 28.6 kilocalories of energy. In that case, three bonds are there. In that case, how much energy should be released? 85.8. 28.6 into 3. That means 85.8 kilocalories of energy should be released. But practically, experimentally, they calculated that only 49.8 kilocalories of energy releasing. 49.8 kilocalories of energy releasing. How much less? 36 kilocalories of energy is releasing less compared to, it is a theoretically it should be this much release, but actually releasing this much. How much difference? 36 is the difference. So this 36 difference is known as resonance energy. Due to the resonance, this compound is getting stabilized. Okay, if you see in the energy diagram, suppose all three pi bonds are not in conjugation, suppose not in conjugation, it is X energy. If it is in the conjugation energy compared to 85, 36 less energy it has. Okay, so after hydrogenation, if you take individual pi bonds which are not in the conjugation, that time if you do the hydrogenation 3H2, it is giving this 1 2 3 4 5 6 7 8 8 means octane is forming. Here octane is forming. 3 moles of hydrogenation takes place. That is releasing 85.8 kilocalories of energy releasing. In case of benzene, here also 3 bonds are there, 3 pi bonds are there, but it is releasing only 49.8. 49.8. Why? Because due to the resonance already it is stabilized, less energy. In case of alkene, it has higher energy. From higher energy to it is coming low. In case of alkene, इसको हम 0 मानते हैं. ठीक है? So it has 85.8 kilocalories of energy is there after hydrogenation, that much of energy releasing. But due to resonance, benzene already stabilized. This energy is less, only 49.8. So if you do the hydrogenation, how much it can release? Only 49.8 it can release. So due to the resonance, how much stabilized? This 36 kilocalories. See, again, stability means what? Less energy means more stable. Less energy indicate direct. Less energy means more stable. More stable. So that means here cyclohexane is more stable than the benzene. Benzene is more stable than octtriene. Okay, it is octene, which is triene. Okay, this is the resonance and the resonance energy. Okay, number of resonance structures are increasing, the stabilization will be increased. One more point you can write it here. The stability is directly proportional to number of resonance structures. Number of resonance structures. Okay. Now, in the next class, we can discuss what is mesomeric effect and applications of mesomeric effect. Right.